Hi again. I call this section the power of two, really just to kind of get you thinking about two, because we're going to look at a few situations where two things are going on. Again, a couple of postulates, and they'll seem obvious to you, but we're just interested in understanding, so obvious is good. So let's take a look. Remember that this is the way that we're going to name a plane. So let's say that this is plane P. That's plane P. Now it doesn't mean this is the edge. Planes don't have edges. They go forever. They extend in all directions, no boundaries. But we can't draw that, so we draw this to represent a plane. So I'm saying that if we have a plane and we locate 2 points in the plane, let's locate those 2 points and name them A and B, that if you want to, remember that postulate that says 2 points determine a line, so then we will draw the line. Then really we have a new postulate. You'll see this one in your book, and it'll be in chapter 1, and it says, in a plane, if there are 2 points that are in a plane, any 2 points in a plane, then the line, the one and only one line that contains those 2 points also lies in that plane or on that plane, whatever makes sense to you. So it just says if you've got 2 points picked out, because the plane is full of millions of points, everything is made up of points. You don't see them unless you name them. So we chose to name 2, we picked out 2, and we said if we've got 2 points in a plane, then we know 2 points determine a line, so that means you've got a line, and it means that that line is also completely lying within that plane. The line goes forever, well, the other plane goes forever. So they're like embedded together, they're right together. If it seems like you already knew that, then it's an innately understood thing. All right, let's talk about this one. This one says, if I've got 2 lines, and we're calling this one line L and this one line M, and if you have 2 lines and they cross somewhere, then they will only cross in exactly one point. Now the word that we use in geometry instead of crossing and everything gets a little sophisticated, so we use the word intersect. Intersect just means if I'm talking about 2 lines that they touch. And so our postulate, and again, remember a postulate is an important idea, an important law. We don't have to prove it, but we have to establish it. And we have to take it in and understand it. So this postulate says if 2 lines intersect, if they do, then they intersect in one and only one point. I mean, think about that. And you can't get them to intersect in 2 points unless you were to bend one of them. And then it wouldn't be a line, because we already said line meant straight line. So if 2 lines intersect, they intersect in a point. The next two-y that I want us to really look at is these 2 parts right here. Now I'm going to tell you, and this is more of a definition, not a postulate. I'm going to tell you that, and when I say I'm going to tell you, normally I'm going to say this is given. In other words, we know this to be true. M is what we call a midpoint in this problem. M is the, because there's only one, midpoint of segment, line segment AB. So I love the abbreviation. I don't have to write out line segment AB. I can just use the symbol, which I always will. So will your book and your teacher. So if M is the midpoint and we haven't defined midpoint, let's see what that means. Midpoint means that that point is placed. You could tell me if I ask you, because it's just something I think that you know already. If it's in the middle, what does that mean? Yeah, it means that this piece is equal to that. It means that that distance is equal to that distance. And we want to mark these little segments that are now formed the same way. It's not like I'm putting equal marks on them, but if I put 3 marks on this one, I put 3 marks on that one, and so that's another shortcut. You look at it and you're like, oh, those are equal. Great. Okay, so that distance is equal to that distance. So I say, this is what I know. if M is the midpoint of AB, segment AB, then what I know, and I have to say it exactly this way, I say that the distance from A to M is equal to the distance from M to B. The distance is equal. That's what midpoint means. You're in the middle, and that distance equals that distance. And we've marked it so we can see it, and we've set it. The reason we know this is that is what the definition of midpoint says. It's a point on a segment, not on a line, on a segment that divides the segment into two parts that have equal measures, two equal measures. So let's take a look at how we wrote that. There's nothing over the top. There's nothing over the top. So it doesn't mean segment, it doesn't mean line. If there's nothing over the top, it means the distance. So get very good at that. Distance equals distance. And again, if there is no notation, there is none, it's just letters, that means the distance from this point to this point, from A to M, equals the distance from this point to this point, from M to B. And so we've stated that we understand that the definition of midpoint tells us that the distance is equal to the distance from that midpoint to each end of the segment. Okay? Now it's a little bit different if we want to actually say that, hey, if these distances are equal, then we've got a little segment here, a new one, and we've got another little segment here, and those segments are actually the same measure, they're the same size. So if we wanted to say that those segments were identical, then we would use this word. It's called congruent. The word is congruent. And the symbol is equal marks with a little squiggle over it. And it means that it's not talking about distance. It's talking about something like a line segment, something that is a thing, if you will. A line segment is congruent to another line segment. So the way I would write that is I would say, oh, okay, I understand that. That means the segment from A to M, see how I put segment on top? The segment from A to M is congruent to the segment from M to B. Okay, and that is what the definition of congruent means. That parts, sides, segments are actually the same measure. So we can say that those segments are congruent. And you might be saying, well, how do you know which one to say? Should I say this way or should I say this way? And we'll be working through that kind of thing as we go, as the details come through. But what I want you to understand is M is a midpoint. Just think. It's in the middle, then that equals that. That's distances. That distance equals that distance. That's what the definition of midpoint tells us. And then, therefore, then that segment is congruent to that segment because of the definition of congruent, because things are congruent if they have the same measure. So, this is actually going to be a piece in our proofs pretty soon. So, I want you to stay with me on the details and resist the urge to say, that's obvious. You've got to stay with the big idea and you've got to stay with the details. You can't do without either one of them. So this is the end of this little section that I wanted to look at things that were true about 2. Let's go over it again quickly though in summary. In summary, in a plane, if 2 points are in a plane, then the line containing them is also in the plane. Also, if 2 lines intersect, then they intersect in a point. A point. And yes, we would label it for sure. Postulates. Definition. If we are given that M, point M, is the midpoint of a segment, we understand that to mean that this distance and this distance are equal. So we write down AM equals MB with nothing over it, and our mind is saying distance equals distance. And then many times we follow that up with another step and we say, it's also very obvious now, if this distance equals this one, that segment is congruent to that segment. So segment AM is congruent to segment MB. So I do want you to get this. I do want you to understand, I'll write it right over here, that distances are equal. Segments are congruent. The distance is a measure. The segment is something that actually exists. Okay? So again, marching on down that road, laying a foundation in your geometry book that you're using, which could be any one. This is perfect match to any of them. Chapter 1 is right where we are. Thank you. See you later. Have a great day.